Hello, welcome to a new unit. This current unit here is about bonding, chemical bonding. And we will focus on three types of bonding first. Ionic bonding, ionic compounds, covalent bonding, covalent compounds, as well as a third type of bond, metallic bonding. You'll have this handout here. This substitute for our notes because I don't like PowerPoint presentation. I just feel like if you provided the notes, you highlight the notes, you study over the notes however you want. You can go and take Cornell notes on this if that's what you're used to, that's your learning style. You can make flashcards if you want to, if that's your style. But here, for our purpose, I'm going to go ahead and highlight the important things, okay? The idea of this reading here, a lot of details, but you need to define what ionic and covalent compounds and metallic compounds are. So it's very repetitive. There's a lot of repetition in here, and you'll see that. Okay, as you read through here, I'm not going to spend time reading it on this video, but I'll highlight some things. Okay, there are, let me see, nonmetals bond to each other to form covalent bonds. That's very important there. While oppositely charged ions, such as metals and nonmetals, form ionic compounds. So there's two definitions there. Ionic compound is formed by metal plus nonmetal. Two nonmetals, two or more nonmetals, will give you covalent bonds. And so they contain ionic bonds or covalent bonds. For most part, ionic. Again, here, ionic compounds contain bonded to a nonmetal. They usually form crystals, high melting and boiling points, hard and brittle, and they form electrolytes in water. That means they dissolve in water and form electrolytes. You probably know about electrolytes in Gatorade and sport drinks, right? Electrolytes help us with our muscles, help our muscles work better. You have to have enough electrolytes to do that, as well as hydration. Okay. And then the next part here, a covalent bond, on the other hand, consisted of nonmetals bonded to each other. All right. And so you have more details here about the crystals, melting point, boiling point, mechanical, comparing both metals and nonmetals here. So read through this, and then right below there are examples of ionic and covalent compounds. Read through that. It's very important for you to notice a couple of things. Remember, we said once you see a metal at the beginning, sodium is a metal, and O and H are nonmetals. But if you see a metal plus a nonmetal, that is immediately ionic. Okay. And down here at the bottom, covalent, from biology, you learn about sugar, C6H12O6. Sucrose is a version of multiple sugars together, and that's all C, H, and O. Those are all nonmetals. So all nonmetals, so nonmetal plus a nonmetal, plus more nonmetals if you want, and that would be covalent. Also known as molecular compounds. So a new word here. Covalent bonds form compounds called molecular compounds. Okay. Those words are interchangeable in a lot of contexts. If I go too fast here, go back and re-watch it. Okay, no big deal. Just read through this. It talks a little more details about covalent and ionic compounds. The last bond is metallic bonds. So metals, they're not really chemically bonded. They're just more like physical bonding. So if you attach two metals together and you put in a something that conducts electricity, has electricity, you will still get shocked, right? So most of the metals that we use are a mixture, or what we call an alloy. So alloy is when they're melted and they're mixed together into a stronger or perhaps a more useful metal. For example, gold itself is not pure gold. It's got gold and silver, or gold and platinum, or gold and other precious, stronger metals. So as far as metallic bond, they have a collective sharing of C of electron. So all the electrons here, these black dots here, they're what we call delocalized electrons. So they talk about here delocalized. Delocalized means they don't stay in one place. They don't stay in. Delocalized means, local is around, it's near. Okay. Delocalized means they can flow all over the place, all over. So they belong to all the other metals that are bonded to or touching it. Okay. So that's what gives them properties. These properties that they give them are properties such as their shiny luster. That's what makes them shiny. Right? They reflect light. Malleability, you can make them into sheets or shape them. Ductility, you can make them into wires. And most of all, they conduct heat and electricity. They would carry heat and electricity. Touch the hood of your car, it's going to be a lot hotter than you touching a spoon that's outside. A plastic spoon, of course. Plastic is not as hot, but if you touch the hood of your car, middle of summer, it's super hot. Okay? And so this table down here will show you the summary of those things. Ionic, couple words to highlight here. Electrons are transferred. Just keyword transfer means ionic. Okay? The shape and all that, but just keywords here. Covalent is shared, and metallic, delocalized electrons. Delocalized electrons, or sea of electrons, another one. And just know the other details as well, but I just want to highlight the key points there. This is all important. You need to know these as well. Okay. And so speaking of that, ionic covalent, we're going to go work on this sheet. It's fairly simple here. You just determine metal or non-metal. You split these elements up. For example, Na and Cl here. You split the two elements, Na and Cl. Okay. There's a couple of them that's hard to read, like P and I here. You might mistake for P and L. It's P and I. Whoever made this worksheet should have used a different font, a better font. Okay. And this one's Al and F, aluminum and fluorine. And we go down, you see O here, it's like, oh, there's only one element. But remember, this is a diatomic. O2 means there's one. The first element is O and the second element is O as well. It's actually bonded like this, a double bond between the two oxygen. Okay, so the rest you should be able to break apart on your own. Okay, then the first step is to determine whether metal or non-metal. So a quick review here. So I have a handy dandy periodic table. We have our metalloids along this line right here. Okay. So general rule of thumb, the left side of it, these are all going to be metals to the left side of that. Okay. To the right side of it, it's going to be non-metals are over here. Okay. And hydrogen belongs over there too. Hydrogen is a non-metal. Everybody else on the left is metals. So the purpose here is to identify metal, ionic or covalent. You need to know if it's metal or non-metal. So sodium is over here to the left side. That is metal. So you write metal. Sodium equals metal. You write M is fine. Chlorine's on the right side of that. That's a non-metal. So if you have a metal and non-metal, ionic bond is metal and non-metal. So then that's ionic. So you just write ionic. Pretty straightforward. Okay. And then S and O. S here is non-metal, right? It's on the right side. S. And then O, oxygen, is non-metal as well. Equals non-metal as well. So, right? So that'll be covalent. Okay? And so you go through and you do that for the rest of this table. So oxygen here, we just did that one, non-metal. We already know non-metal. Oxygen is also non-metal here, so that we have that covalent as well. So the definition, key definition here on this page is ionic bond, metal, non-metal. Covalent bond, non-metal, non-metal. Okay, we should be able to finish this page. Let me see if there's any other one that might be confusing here. CCl4, yeah, this is carbon and chlorine here, Cl. Yeah, everything else looks good. Yes, go ahead and finish this page, and I'll make the next video for the next sheet.